When working with very large or very small numbers, it's sometimes useful to write those numbers in scientific notation. Scientific notation is writing a number as a number between 1 and 10, including 1, times the power of 10 that gives us the original number. For example, if I take the value 32,500 and write it in scientific notation, I first want to write it as a value between 1 and 10, in this case 3.25, a single digit in front of the decimal point, times the power of 10, that would give us 32,500. In this case, we have a decimal point move of 1, 2, 3, 4 places, so I have 3.25 times 10 to the 4th power. A small number, like this one, can be written as scientific notation by moving the decimal point, giving us a value between 1 and 10, 4.2. Times the power of 10 to give us the equivalent of this value. I can move the decimal point 1, 2, 3, 4, 5 places to the right to put it after the 4. So in scientific notation, this number would be written as 4.2 times 10 to the negative 5th power. We can also take numbers written in scientific notation and write them in decimal notation. In this case, I have 6.2 times 10 to the 5th. I still need the 6 and the 2, but I need to move the decimal point 5 places to the right for the 10 to the 5th, including zeros wherever needed as place fillers. 1, 2, 3, 4, 5. And in this case, my value is 620,000. Or if I have a negative exponent when writing the number in scientific notation, 8.4 times 10 to the negative 6th. I still have the 8 and the 4, but I need to move the decimal point 6 places to the left, including zeros where needed for place values. 1, 2, 3, 4, 5, 6. And here's my number written in decimal notation. Let me give you a problem to practice. 2.5 times 10 to the negative 3rd. Write that number in decimal notation. Pause the video and then come back to it when you're finished. In this problem, we still have the 2 and the 5. We need to move the decimal point 3 places to the left to give us a small number. 1, 2, 3, including zeros where needed. I have 0.0025. Another example. Let's take the decimal 0.000812 and write it in scientific notation. Pause the video and come back to check your answer. For this problem, we still have the 8, the 1, and the 2. I need the decimal point moved after the 8 to give me a number between 1 and 10, times the power of 10 to give us the equivalent of this initial value. I'm moving the decimal point 1, 2, 3, 4 places to the right, which would be 10 to the negative 4th. For my exponent, 8.12 times 10 to the negative 4th. When we work with multiplication and division problems in scientific notation, then we need to use our laws of exponents that we just took in the other section. For example, let's say we have the problem 1.8 times 10 to the 4th times 3.5 times 10 to the negative 8th. I can expand each one of these into decimal notation and then multiply, or I can multiply the numerical parts first and then combine the decimal parts using the rules of exponents. In this case, if I multiply 1.8 times 3.5, I get 6.3. Times 10 to the power of, I have 10 to the 4th and 10 to the negative 8th. I'm multiplying, so I add the exponents, 10 to the negative 4th. Let me give you an example that you can practice with. 4.8 times 10 to the negative 3rd divided by 6.5 times 10 to the 8th. Pause the video and come back to check your answer. In this problem, if we divide 4.8 divided by 6.5, we get approximately 0.738. And from my exponents, 10 to the negative third, 10 to the 8th, I can subtract the exponents to get 10 to the negative 11th. I still don't have this in scientific notation, though, and I probably should rewrite it in scientific notation because we started with scientific notation. So I can rewrite this, the 7.38 as 7, or the 0.738 as 7.38 times 10 to the negative first times 10 to the negative 11th that I had. And combining my powers of 10, 7.38 times 10 to the negative 12th. One more example, or one more practice problem. Simplify this problem using the scientific notation, using laws of exponents. Pause the video and come back to check your answer. In this problem, if we perform the multiplication and division, the 2.3 times 6.5, and then divide that by 8.9, we get approximately 1.68. If I combine my exponents, I have 10 to the negative fourth, 10 to the sixth, and 10 to the negative third. I can add the exponents in the numerator to get 10 to the second, and then subtract the exponent, the negative 3, from the bottom. I have 10 to the fifth power. My answer is 1.68 times 10 to the fifth. In conclusion, scientific notation is used to express very large or very small numbers in an efficient manner. We can also use the laws of exponents to simplify expressions involving multiplication and division in scientific notation.